All right. So my name is Matthias. I'm the CEO of Artling. This is our very first meetup. Thank you for coming. I welcome people interrupting me with questions, or you can ask them in chat, and then Theo can relay the questions, or we can have some time for questions at the end as well. I'd like to open the floor at the end and have maybe a bit of a discussion if people are up for that. So Artling, yeah, Theo mentioned it a bit already. We are a software consultancy. We are very much focused on the sort of complex business domains. A lot of our clients are finance or supply chain or these sort of very large, messy domains. Automotive sometimes, things like that. And I'll have some examples later on as well. We help with domain modeling and software design first and foremost. But often we also are more on the sort of strategic side, making sure that the the software design efforts actually have an impact, which involves looking at the more holistically, right? You need the right team organization, you need the skills, you need the alignment with business vision and product vision and all these kind of things. And that's what we do for our clients. We're also the organizers of Domain-Driven Design Europe, which is a conference. The next one is happening in Amsterdam end of May. So you can find that at ddeurope.com. And I'm also the author of a book called Design and Reality, which covers some software design topics that I wrote together with Rebecca Wersbrock. And yeah, that's the TLDR about myself. So I want to talk. I don't want to have like a long discussion first on what domain-driven design is. There's plenty of resources for that. And I sort of hate presentations that start with the definition. So there's a link you can go read or attempt at a short description of what it is. But I do want to talk a little bit about what you do when you do domain-driven design, because some of this will be relevant later. So it's not really a definition, as more like a set of here are the main things you would be doing if you're trying to do domain-driven design in your organization. Some people call it an applied philosophy, which I think is quite accurate, but I think it's not a very marketable term to call something a philosophy. That will scare a lot of people who are more oriented at the pragmatic side. But it is very pragmatic. It's people sort of misread domain-driven design as being this sort of highly academic theoretical thing, but that was never the intention. It just sort of gives that impression for reasons I don't need to get into now. But I like to think of it as a design discipline, right? A software design discipline. A discipline is something where if you apply the principles, if you do like build up the habits, then you will get the benefits that it promises. And we'll be talking, of course, about some of those benefits for the rest of the presentation. But some of these sort of habits that you need to build are listed here, right? First of all, it's specifically meant for complex domains. That's a bit of a filter because if you do all this work for something that is quite simple, like, I don't know, you're making a website for the Christmas campaign, and then after 6 weeks you'll delete that website. That's usually not the kind of thing where you would want to apply a lot of domain-driven design thinking. But if you're doing something that needs to last for many years and that will evolve, and that involves complex business domains with lots of processes and rules, and maybe there's some regulation, maybe there's a lot of competition, or maybe it's just naturally complex because it has to deal with a lot of things. So it's specifically a discipline to deal with these very complex domains and how to make software for that. Um, and it does that at the sort of micro level of code. It does that at the higher level of architecture and sort of system design and the boundaries, and then at the highest level, even of sort of integration between not just systems but
Interesting.
systems
Interesting.
of systems. So yeah, it's specifically for these domains, usually with a lot of people involved as well, where it's hard for one person to see the big picture, right? Or just to understand everything. Um, and so the idea is that you will try to, I called it grasp here, but try to get some understanding of these domains. You don't need to become as a software engineer or an architect or in general a software designer. You don't need to understand everything about them, but you need to sort of get a sense of how they work and why they work that way. Um, I like to think of that as like it's not just learning business rules, but if you can or learn every individual like accounting rule or something, but more like what's the underlying principle, right? What drives this? Uh, I like to look for risk, for example. What sort of risks does this business have, and is it trying to avoid? And then you can understand better you know, why the rules are the way they are. So I'm sort of looking for this overarching themes and concepts and see if I can sort of grasp that and use that to build software that will be more suitable to not just implement but also evolve these rules and processes. The second thing is that it's very much focused on language. At the very core of domain-driven design is this idea that language as the central thing that we use to communicate, and that a lot of complexity, accidental complexity, is the result of sort of misunderstood language, people having different terminology for things. Um, Especially like a divide between the people in the business on the one hand, and then the software designers on the other hand. Um, if you are a programmer, you've probably seen code that is like highly technical, but you don't really see in the code what it's about or what it's for. Um, it doesn't communicate in the same language as the business and the domain experts. So that's something where we put a lot of emphasis on, right? Let's try to find a shared common language. I'll talk a little bit more about that later as well. And then modeling is the next sort of big thing, right? It's this idea that the way I think about that is we're always modeling. We're always making mental models, right? Right now we have this conversation. Well, it's me talking to you mostly, but I have a mental model of what domain-driven design is. I'm trying to change the mental model that you have in your head, um, and I don't know how successful I am, but if we visualize this together, right, this collaborative, this shared modeling ID, if we get a whiteboard or some visualization tool like Miro, and we try to draw how we see it in our heads, we will be able to communicate it better. We will be able to understand, okay, you got this, or it seems like you're missing something. Um, so that idea is very strong in domain-driven design, right? We don't just um, build software based off, a conversation or a specification document or something like that, or requirements or a backlog of features. But we try to really understand, okay, how do we see this domain? And that's another big thing, right? It's not just system models. It's not just a model of how the software works. It's not just a model of the data structures or the database schema, but it's a model of the problem itself, of the problem domain. Let's model how people think and work and do things in this business. And then let's use that as the model that we will also use in our code and other artifacts like documentation, tests, etc. So it all has this sort of same way of thinking about it, and we try to make that very explicit. In practice, a lot of people, just make a data model and call it a day. That's unfortunate because there's so much stuff you don't see on a data model, which is all the behavior and the processes and the rules, etc. Those can also, and should be part of that model because that's where the important and the interesting things happen. We're not just building software to store information, right? We're doing it to manage our business processes, etc. And so this whole idea of complexity, right? It's always
Matis,
like
maybe before you
sorry.
jump onto that subject, we just got a question from Omar who says, "What is the definition of domain as it can have a few meanings in this context?" So, what are we
Yes.
talking about when we're talking about domain?
Yeah. I wouldn't want to go too much into detail for that, but roughly a domain is an area that a business is active in. That's like a close enough intuition for it, I think. So if you're, I don't know, a car rental company, you could say our domain is mobility, which is very sort of high level and broad. But you'll probably want to specify that a bit more. So you'll say our domain is, or core domain is car rentals. And then as part of how do we deliver this service to our customers are a bunch of other domains as well. Some of them are very specific to us. Maybe we have, the way we calculate prices or market this or whatever could be very specific to our business. And then some other subdomains would be very generic and sort of universal across many organizations. Like we all have invoicing and accounting and finance, and these are sort of more generic domains that we deal in. But so roughly, it's an area, a sphere of activity and knowledge that an organization operates in. Um, and like I think the main intuition is just something that the business cares about a lot, uh, that we'll need to deal with somehow. And not everything is going to be relevant for software designers, right? There's a lot of things like maybe you just buy an off-the-shelf accounting software and that's enough, right? You don't need to reinvent that. But for the things that are very specific to your organization, you'll want to build uh, build that yourself, build software for those subdomains yourself. And then the rest of the talk will be about how we actually, how that doing that with domain-driven design can give us business value. Um, Another way to maybe think about domains, like another way of forming an intuition for that, um, it's sort of if you're a software designer, it's the stuff you don't have control over, which is it's not really a good definition, right? It's more like a what's our role in this? So if I'm tasked with building software for the car rental company, they have a way of doing things, how they want to schedule the cars or how they want to make the reservations. And that's not really up to me to decide. That's sort of the problem space that's given to us, and we have to solve for that. Um, so that's the domain really. We don't like we could spend a lot of time philosophizing about what it is and what it is not, but I think it's sort of pragmatic enough to just have sort of an intuition of stuff the business does and cares about that we need to build for and that
Thanks
we
for that.
don't necessarily have control over.
Yeah, I didn't want to go down a rabbit hole because my initial investigation around the discipline, I was like, I wasn't tracking how domain was being defined, like it was being used in different contexts, but that's helped. So thank you.
All right.
I don't want to go down
Um,
a Oh.
Yeah, I could talk about this for hours, but maybe we should,
Yeah,
if
no, no,
you
no.
want more in depth,
Thank
we
you.
can do it after the. But it's a
Yeah.
good question, right? It's important that we get these things to some degree. I think I left off at the embracing complexity, right? So a lot of times we value simplicity. Um, there's the quote attributed to Einstein that make everything as simple as possible, but not one bit simpler. And people forget that second part. What that means is that some things just are naturally complex, and hiding that complexity or ignoring it will make that complexity turn up elsewhere again. That complexity, if you try to hide it, if you try to get away from it, it turns out it's like thermodynamics of complexity, right? The amount of complexity is constant, and it will turn up somewhere. It might not turn up in the software, might turn up in, like, if I make software that doesn't address a complex business process and just gives people a very simple UI where they can add data or change data, then they will have to be trained in that process instead of the software doing it for them. So that complexity turns up elsewhere. So domain-driven design sort of really embraces that and says, no, let's look for that complexity. That's the thing that's going to hurt us in the future. So let's actually start looking for it. Let's try to make it very explicit. That goes back to the modeling and the language. Like, what is the name for this thing? How can we draw this? Can we put that in the model, right? Instead of here's just a data structure. It's like, okay, there's rules about how this structure evolves. Let's put that in our visualization. If something, if there's two types of something, you want to make that explicit. Like a simple example could be if you have customers and then it turns out maybe it's like a SaaS or something. And over time, you also start servicing corporate customers. So you have maybe uh, just private individuals using your tool, and later corporates want to use it. You could say, well, it's just the same customer model. I will just add some extra fields in there. But the reality is that this corporate account is probably going to have different behaviors and different rules, etc. So embracing complexity means that, okay, I'm going to figure out, should I make this two separate types, the corporate customer and the private customer? Can we make the differences explicit? Can we deliberately look for those differences? I think there's sometimes sort of a misunderstanding that modeling is the art of making things as generic as possible, like the ultimately reusable things, whether that's at sort of the drawing stage or the coding stage. I once, well, talking about car rentals, somebody in a modeling session tried to convince me and the other people in that company that renting a car is really just like buying a product, and that they should just use a generic sort of e-commerce model where cars were just products. But if you start looking for if you start looking for the similarities, you will find them. But if you look for the differences, you will find where the real complexity is. And that's just one example, right? DDD is really just admitting that, some problems just are naturally complex. Let's actually, make that visible. If it's visible, we can deal with it and we can start managing complexity. Um, the downside with that is sometimes people will say, oh, but DDD makes everything more complex. Well, if it's done badly, sure, right? But if it's done well, it doesn't make it more complex. It just shows the complexity, and now you can actually deal with it and figure out ways to manage and contain that complexity.
We have a question kind of related
Sure.
it's kind of, we say that DDD, it helps grasping complex domains, but do you have these kind of guidelines or, I guess, heuristics when you are determining how to apply it?
That's a great question as well. That's also would be a longer discussion, of course. But if you're really dealing with a complex domain, right? For example, I worked in energy trading, and energy trading is very different from financial trading for many reasons. One of them, which I learned back then, is that if you have Well, a dollar in New York is a dollar in Paris. But if you have, I don't know, oil or coal or whatever in New York, you can't just, move that to Paris. There's a cost in moving it. Apparently, the quality of coal uh, changes depending on the climate conditions of where you travel. So if you take like a more northern route or more southern route, you might end up with coal that is changed somehow. I don't know the details, but that's one of those like things I never thought about that I picked up. And then but what I did, which is my point, right? I didn't just interview people or sort of waited until I through osmosis sort of picked up ideas. I read some books on energy trading. I did some research, right? And I think that's sort of underestimated. Um, there's a huge value in really trying to understand how these things, how these domains work, and find people and be naive, right? And ask the stupid questions. You know, smart people will never blame you for trying to understand something. The reason why it's hard is because software design and software engineering is so hard and so huge on its own already, right? There's so much, like, you can't keep up with the speed that it's going. Um, and then we sort of, I think we believe as engineers that our value is purely in our engineering skills, and our peers sort of, will admire us for our engineering jobs. Um, but we can get really valuable if we bother to really understand a domain, or at least to a degree good enough that we can, that we get an advantage building software for it. And then we think, well, if I learn this, energy trading domain now, and in 1 or 2 or 5 years I will go somewhere else, that skill will be useless. Well, first of all, you could go to another energy trading company, and you'd be more valuable. But it's not just the skill of knowing that particular domain that is valuable, but if you get better at learning complex domains fast, that also makes you much more valuable, right? So we're not just building technical systems, we're building systems that solve business needs, and being able to do that is but I'm sort of deviating from your original question, which is more like how do we do that? So interviewing people, reading, and doing. How do you learn anything, right? It's study, it's practice. Um, find yourself in situations where people will talk about these things. Um, there's there's Google. Like I do a lot of consulting with financial companies, often remote, and then I have Investopedia open in one tab somewhere, so I can quickly, if they mention some term that I don't know, I can just search it up there. It usually has like 3 bullet points explaining the thing, and there's a lot of stuff where I just learned it that way. Where often even sometimes people working in the domain don't know what an acronym is anymore, right? So you even get an advantage that they can learn something from you at the. But yeah, it's like just bothering to do the effort is a of trying to grasp that domain is important. So moving on to separating models in context, right? So the way, like a lot of what we do in domain-driven design is not for the system itself, right? It's not to make the technical system work. It's to build a system in a way that we can manage the complexity, that we can keep evolving the system, that it can keep delivering business value, that we can, introduce new people in the system without them having to spend like a year before they become productive, right? So we're basically trying to build systems that we can understand and maintain and evolve. And the way we always deal with complexity is compartmentalizing, right? So a bounded context in DD terminology is this idea of, well, we have that language, we have those models, but this organization and this domain are so large and complex that trying to build this one huge universal language for the entire business just doesn't work. People have attempted that, right? Let's make the universal model that will describe the whole business. By the time you finished making it, first of all, it's always going to be too bloated in some parts and under modeled in other parts. And by the time you finished, it's already outdated because stuff moves on. So we need to define like smaller areas and say within this little boundary here, within this context, we have a language. We have models for this. And then in this other context, we might have a different language that is not consistent with that first language. We have different models. We might have different business rules and everything. We're not trying to make everything sort of universal and speaking the same language, but we're drawing very clear lines around those boundaries so we can do these things in isolation, and then you can manage complexity better. That's a short version. We'll talk a bit more about it. But that's the idea, right? It's how do we manage that complexity? Well, figure out some parts that belong logically together and focus on those in isolation. Find some other parts that belong together, focus on those in isolation, and then maybe think about how they communicate, which is a third language, right? That's a third language between these two things with their own language. Well, it doesn't have to be, but it can be a third language. It can also be that one uses the language of the other. But we're sort of very careful about these boundaries and sort of really thinking what belongs here, what belongs there. The opposite of that, to give you some intuition as well, the opposite would be, oh, there's a team available to build this new feature, and they just sort of touch code wherever, and they use the words that they're used to, and they have like a different interpretation for some words, and it's all very sort of subtle. So we're trying to do the opposite, right? We're trying to really control that language and draw lines in the sand and keep those clean. And then the last thing that is sort of undervalued maybe as well is this idea of this continuous evolution, right? You just can't in a complex domain. You can't just make a model and pick some terminology and call it a day, because the business evolves. That's like one of the largest or most important sources of complexity, is that this business is always going to be evolving. Unless you are in a very lucky and rare situation where you find some very stable business with no competition and you remain the only one doing it forever and the demand remains equally high forever, etc. Right? But that doesn't happen. We're always like adding new things, competing, reacting to market changes, reacting to regulatory changes, reacting to new technology. And I'm saying the word react a lot, but some of that should be proactive. Let's innovate. Let's try to discover new ways of doing things that will give us an edge. So that's where a lot of complexity comes from. Right? So that language, like every design choice you ever make, is always made at the point where you sort of know the least about it, right? And then afterwards, as you put it in production, as you gain experience, you will figure out, oh, wait a minute, that would have been a better way to do it. And then, so what we say in domain-driven design is, if you have this sort of change in the language, if you have a change in the model, then the software should reflect that, and vice versa, right? If by building the software we learn a bit more about the domain and how it should work or could work, we will try to synchronize that language and those models. And I'm using the word model very broadly, right? It's not just in the software itself, it's any representation. It's how we think about it, it's how we draw it, it's how we talk about it, it's how we put it in the user interface and the documentation and the tests, any artifacts really. That's the model, and that you need to accept that as being in a constant state of flux. If you don't co-evolve that, right? Let's say the business changes and maybe there's new terminal, or even that simple example of, we start servicing corporate customers now, if we don't make that change explicit in the models and in the software, then something happens that I call model drift. Right, the model in the system is starting to drift from the mental model that people have in the business, and that feels very like innocent and not very important for each individual time that happens. Like, oh yeah, but we know that customer can both mean corporate customer or private customer. But over time, all these sort of little model drift instances start adding up, and now you have a system where, oh yeah, this here, this field actually means this other thing, except during a full moon, then it means this other thing. Like, I'm joking, of course, but this sort of situation where the systems and the software become so different from the mental models that it just becomes impossible to evolve them. So that's sort of the idea, right? That's the stuff that you do. And the business value of that, which is really what I wanted to talk about today, right? Like some of that should be quite obvious, right? If we can agree on language, we'll have better communication, right? That's a valuable thing. We know that, right? That's not like I'm saying something weird here. If we have shared models, if we can, solve or at least manage the complexity, that's going to help us in the long term, etc. So I think a lot of the business value should be obvious, but I want to talk about some that are maybe a little bit less obvious, and then at the end, that's some that are maybe completely novel for most people. Some that I haven't encountered or that so let's move on. So DDD practitioners can be a bit hand wavy about business value. It's sort of, oh, let's solve problems for the business. Let's talk to domain experts. And then we go sort of back into coding and models and bounded context and all this stuff that the business people don't care about or don't need or want to understand. So it's not that they're wrong, right? I do think that if we grasp the domain and make good models, it's going to deliver business value. But it's not always communicated well how that will happen, and that prevents adoption of DDD, I think, because we sort of make it about ourselves as engineers instead of making it about really, how that business value will get expressed for that business. This is a mental framework that I use. It's that what we're doing with domain-driven design or any sort of software design activity in general, right, is that it's invisible design. The word design has sort of been co-opted too much by anything visual, right? Graphic design, UX design, furniture design. It's even that bad that in some context, if you say design, people automatically assume that it means something you can see. Design is, of course, how it works as well. It's the sort of, the marriage of form and function, all of that. And the invisible design, which is the structure of the software, right? And at the small level, codes, objects, classes, patterns. At the larger level, the architecture, the organization, the communication between different parts. All of that is invisible design that doesn't have an immediate visible impact, right? The purpose of that invisible design is to help us as designers to design the software, which sounds a bit tautological level. It is, I guess, but if we have a better software architecture or better software design, we will be able to do more good software design. That's basically it, right? The machine doesn't care, right? The machine doesn't care if you named everything well or if the names are a mess. As long as it compiles and runs, the machine couldn't care less. But we care about it, right? Can we still understand this system? If we were all extremely, geniuses with a 200 IQ, we could probably just write machine language and still make sense of it. But that's, we can't do that. We can't scale software that way. But that's like a bottleneck, right? The fact that all this software design effort is very invisible doesn't help its case, right? So I'm using this as a sort of a framework for explaining to people why this works is important, even if they can't see it, right? So it's not a bad thing, right? That we're designing to make our own design work better. If we have a better sort of design or developer experience, the engineers will be more motivated. They will feel like they know what they're working on and why they're working on it and how their work has impact, etc. If you are more motivated, if you are happier at your job, you will build better products. That's the sort of indirect way that good software design makes for happier people, and happier people makes for better output. It's this is so clear to people who have experienced it that it's weird that sort of capitalism doesn't care more about keeping people happy, right? Because they would make better things that way. Smart companies do, of course. Smart companies make sure that the people who work there are comfortable and safe and are able to do be productive and work in a good environment and all that. And it's not just design, right? It's also tooling. It's also how people communicate and collaborate and all of that. But it doesn't make the case for domain-driven design because it's invisible, right? I've heard people tell me, oh, you care too much about that stuff that nobody sees anyway. You don't see it. The difficulty with invisibility is that you can't see it, right? Managers can't see it. Don't blame them, right? It's not their fault, right? It's not their job to understand the internals of the system. But it makes it harder to sort of build for them. Sorry, I moved a bit too fast. So I think as a community we've underestimated how hard it is to explain the value of this kind of invisible design work. And that's also a bit what I'm trying to do here today, of course. So another way to start approaching this, right, is that engineers will build what they understand, right? It's not what the customer wants. It's not what the business analyst wrote down. That helps, of course, right? But in the end, it's what the engineers understand. That's what they will build. If they have a good understanding of the thing they're building, they will build a better thing. That's quite obvious to me, but like one of the things, maybe a funny thing about domain-driven design, if I explain domain-driven design to people who are not involved with software at all, they say like, yeah, that's so obvious. Why does that even have a name? That's like, how else would you do it? In reality, we sort of shield engineers from understanding the domain, right? And I keep saying engineers, but I sort of mean system designers in general, right? Which is everybody who has some impact on the design, which could be analysts, which could be testers or product people or anyone who sort of makes decisions at the large or the small level that impact the final design. So that includes project managers often and even salespeople. If you sell something to a customer and then you need to build that, you have already made a design choice. So an extension of this is that your salespeople should understand your domain as well, but that also probably doesn't happen as much as it should. But if we accept this premise, right, which obviously I do, that engineers will not build something that they don't understand, they will only build something. I mean, they will build something for it, but it won't work well for the thing. It might superficially work, but it will not work in depth sustainably for a long time because it will get muddier and harder to actually evolve. So if we accept this this premise, then what we should do is optimize this knowledge transfer from users and domain experts to engineers and designers in general. That's another way of explaining what domain-driven design tries to do, right? It's saying don't put people in silos, don't shield them, don't just tell an engineer or designer add a button there that makes the thing there move in that way or change that thing. It's like, here's the purpose, here's the problem we're trying to solve. Help us build a solution for that. And that's what domain-driven design does by trying to, have a shared language, have shared models, etc. Right? That those ideas, and then this idea of bounded context, of isolating models and language in a smaller area, because it's much easier to transfer knowledge for a small, well-defined area than for a large, sort of messy, infinite blob of things. Another thing is strategic DDD, right? I feel that the DDD community has sort of reduced the notion of strategic DDD to, let's pick some bounded context, right? Let's draw some boundaries on like day one of the start of a new project, and we're done. That's not being strategic, right? That's just sort of creating some order in the universe. Strategic is making sure that all this design effort, right, all this invisible design, that it does focus on long-term business goals, not short-term, because if you only have short-term business goals, then just build something quickly and ship it and be done with it. But if you want to build something that will be productive for you for a long time, that's where DDD is relevant. So I think we sort of reduced the notion of strategic DDD to something very narrow. We should see it a lot bigger, right? It's what is this business trying to achieve? Where does it see itself in 6 months and 5 years and 50 years? And then where should we focus our effort? Should we spend a lot of time modeling this thing? No, because it's not going to have a big impact on this business in the future. Or yes, because, or no, because we're going to actually sell that part off. We just want to make it good enough now so we can convince the investor to buy it. And I've been in that situation, right, where it turned out that there was no point in doing something well, because unknown to most of the people in the organization, it turned out that actually this thing wasn't going to exist anymore in 6 months, or not exist in this company. So strategic design is then not spending design effort on that. Domain-driven design is definitely not this sort of let's make everything perfect, which you can't. It's as I said, it's very pragmatic, right? Let's make the things close to perfect where we believe we'll get an advantage of that, and if not, let's move on to something else that might benefit more from this design effort.
Maybe while you're just on that subject, Mathias, there was a question about the perception of DDD. So Alexander asked about the perception of DDD being very technical, and you've spoken about it being academic. And I guess a big challenge for people that want to implement DDD is convincing others of that it's not academic or it's too technical. I guess how do you think about that?
Maybe a more fair way to say it would be that yes, it is academic and it is philosophical and it is technical and it is very business focused. It's a very large set of ideas. One thing that makes DDD different is that it's not just talking about one aspect of software or software design or development, but sort of on the holistic thing, from the very small to the very large. Too technical, yes. If you're not technical at all, DDD is going to sound very technical. Or if you don't, like, DDD does have a lot of jargon, a lot of specific terminology. That's not a bad thing, right? That's how you deal with complex things. DDD itself is complex. It has to be complex because it's trying to solve or manage complex problems, right? You can't, if somebody tells you, here's the easy 3-step way to solve this very complex problem, they're lying or they're trying to sell you something, or they just don't understand it. But you can't solve for complex environments with very simple tools that don't really, address that complexity. So DDD is going to be technical. It is going to have like very, technical language about patterns and programming patterns and architectural patterns, etc., that make sense to programmers or that make sense to architects. It's going to have patterns for modeling that make sense to people who spend time modeling. You will need time to get into that and to learn this thing. Well, you don't expect to walk into like a heart surgery conference and be able to have a conversation with the other participants there. They have spent years studying um, everything there is to know about heart surgery. They will say things that you don't understand. That's normal. The reason we have jargon is because it allows us to talk about things in a sort of very compressed, efficient way, right? Um, just I don't know, like a simple example, just because it pops in my head, but we don't say we had a situation where two people would say some sentences and then the other person would say some sentences and it would keep going on like that for a bit. We would just say they had a conversation. Conversation is jargon for a sort of, uh, way of communication between people. So DDD has a lot of that, right? It's sort of a pattern language. It's a lot of things that people are doing or were already doing before it had a name. And some things are sort of innovation as well, but it's like looking at these things and saying, well, let's put a label on that. Let's give that a name so that we can sort of think about it and have a higher order conversation about it. So yes, it's going to be technical. For people, well, and even depending on where you are, right? If you are a programmer, then architecture is going to sound like abstract and people say these sort of weird things that you don't know how that translates into code. If you're on the side of, I don't know, business analysis, then programmers will sound too technical to you. If you've never, hung hung out with marketing people, then everything they say sounds abstract and weird and vague and whatever, right? You sort of know the words, but at the same time, you don't really know what they mean. So that's normal. And we are trying, we're trying to solve for complex things. That's going to involve technical aspects as well, right? In the end, it needs to be pragmatic. It needs to, we want to build something that works and that we can ship and that works for us in the long term.
Just to elaborate on my question, I'm asking myself if it is non-technical enough to be usable at the higher management levels. Do you have experience with that?
I have an example about that later. But yes, that's evolving. For whatever reason, DDD started, and probably because there's sort of programming patterns in the book, etc. It's always been this sort of grassroots thing originally, like 20 years ago when it started, where it's mostly engineers and then architects sort of looking into it, and that is changing. There's more and more people on the business side who are starting to see like this makes sense. We need to get this to a certain point. They figure out that they don't need to know all the details about it, but that there's some of the language and the habits and the practices like Eventstorming and modeling are useful from their point of view. But I'll give you the example in a moment. But it's just a difficult problem, right? We're solving difficult problems, and we're going to need people with different skills and backgrounds to get a bit more technical than they're comfortable with, or get a bit more to the business side than they're comfortable with. Without that, we'll have silos, and it's just not going to work. So this is how like the very summary of what strategic DDD should be, right? It's the business has a vision and a strategy. Hopefully, if they don't, work on that first, and then how does not just the software itself solve for that, but also how are we going to organize, and what are we going to focus on, and where is the effort going to go? Which people should we put on what things, right? Put your best people on the most business critical core things. One remark that I will never forget, and I forgot who said it, but your oldest code in your system should probably be your best code. And the reason is because that's probably the most core to your business. In a real, and people are surprised by this statement because most of the time the oldest code is the worst code. Business strategy can be, well, if so much depends on this old code, let's make sure we really, it really works for us and it's really clean and well modeled and well designed. That's one example of a software strategy that works for the business, right? But it could be, some of the other examples I gave, right? This is not worth building ourselves. Sure, you can make a JSON parser that is 1 millisecond faster than the one you have, but is that going to be valuable to this business, right? That sort of thinking is what I'm talking about. Another way of looking at this is that traditionally software is like a cost center, right? It's something that you throw money at, and then 6 months later you get, some features and some bugs back. That is not true anymore, right? All companies are software companies today. Some of them are just bad at it, but and the evidence is there, right? If you look at all the biggest companies right now, even Tesla, which is a car company, is led by somebody who has a background in software and really understands software, even though he might have become a bit, I don't know, under the influence of substances lately. But it's somebody who really understood the value of software as well. Same with, Amazon, Facebook, Microsoft, all of them, Google. Anyway, let's talk about this example, right? Ubiquitous language so this is the more sort of less obvious business value of domain-driven design. I really love this case. Unfortunately, I can't really name names here, but we'll just talk about it in the broad. First of all, I want to sort of clear up this a bit. Domain language and ubiquitous language, people sort of mix them. I think it's more valuable to see them as two very different things with a relationship between them. The way I think about it is that domain language is what's spoken in the business by the people working in that domain. So domain experts, users, maybe just people who, I don't know, in finance, it could be traders, it could be in logistics, it could be people who plan things, or people who, whatever, drive the things or do the process. And what happens in any environment is that people will develop language to talk about their thing. They will have jargon, right? They will come up with words that are, some of them will be sort of universal to their domain, especially in mature domains like in accounting. That language is very mature. It's, some of it is actually very formal and defined by law. But still, like specific processes or ways of doing things or specific rules or concepts will have sort of names, acquire them organically. Any social group has that, right? This language is very social. If you're in a social group, you will evolve a language that helps you solve the problems of that group. But this language is very undesigned, right? It's not that people sort of get together and say, hey, we keep dealing with this process here. Let's come up with a name for it. It's more like stuff acquires names. There are names from other things that are being, used in a different sense, or they are sort of combinations of other names, or they make an acronym and then the acronym become name and people forget what the acronym is for. It's words get double meaning, so the language can become very ambiguous. People, might use the same word for a different thing, or use a different word for the same thing, or use a different word for the same thing, but think it's the same thing, but it's actually a slightly different thing. One example that pops into my head. We did some consulting for Spotify. They have playlists. If you think you know what a playlist is at Spotify, well, there's at least like 7 or 8 definitions, and then probably a bunch more. They've used playlists for audiobooks. So an audiobook is a playlist of chapters. An album is a playlist of songs. All this. A podcast is a playlist of episodes, and then all the sort of subtle differences in many parts of the system where playlist has a different meaning. When I was working with them, they actually hired some ontologists as well to sort of make sense of that. And not just that one word, of course, the whole language. But the language becomes very ambiguous, and the more people are involved, and it sort of branches off and diverts, etc. You can't just fix a language like that, right? You can't just force language on people. That's maybe an important thing to understand. But what we can do is look at the language and try to sort of capture it. And then what we do in domain-driven design, we make this very explicit, right? We have a name for that. We call it ubiquitous language. That is the idea of let's find that domain language. Let's structure. Let's formalize it. Let's sort of agree on what meanings are, right? Let's deliberately build a language that works for us. For us, meaning the designers in the first place. So we need that, right? If we want to build software, we need to be precise about language, at least for now. Maybe with AI that will change. But right now, we still need to write code where everything is spelled correctly, or the compiler will trip on it. So we need to be a lot more aware of that language. If we don't do that, you get these sort of systems where the same thing has 3 different names in 3 different places, and then it sort of becomes messy and all of that. And you need to sort of like ask someone, what is this for? Oh, well, it's called that, but it's because it was actually first that, and then it's changed like that. If those people are still around even, so you sort of lose a lot of meaning if you don't capture that language well. So, and this idea of ubiquitous, and when I say formal, right, that's very context specific, right? If you are, a fast-moving startup, then formal, and with like 5 people, then formal means, hey, should we call it that? Yeah, that makes sense, and that's formal enough. If you are, the opposite example would be you are the designer of the HTTP spec. You have like a 10-year RFC process. And a hyper-formal language, right, that you sort of build there, and that everybody is expected to use very strictly. And it can be anything in between, right? If you deal with, life-critical systems, you're going to want to be a lot more formal. I've worked on software for drug pumps for hospitals, so for chemotherapy patients, etc. You're injecting people with poison. You want to have a very like well-defined, strict, formal language in a situation like that. And as I already mentioned, some languages are already formal in the domain, like accounting has laws that sort of define some of the terminology, etc. You want to get rid of the ambiguity, etc. But that's not just a programmer's language, right? That's where a lot of software goes wrong. It sort of becomes, oh, we already have the word order. Well, let's just come up with another name for this other class here. And then that name doesn't exist in the domain. That should be an agreement, right? You should talk to the domain people and the domain expert and say, well, there doesn't seem to be a name for this, or do you have a name, or what would you call this? And then can we agree on that name? Oh, that doesn't work for us because we're using it there, or that sort of discussion is critical. So the basic idea of ubiquitous language is if we, the designers, have a very clear, well agreed upon language that we might evolve, right? But we have this language, we can build better systems. We can still understand these systems over time. We can go back to the business people. They come to us with changes, and we can talk about those changes in a shared language. They say, well, this rule here should now also be applied in this business process. We can look in the code and we see this rule with the same name and we see this business process with the same name that they use, we all agree upon it. And then it's very clear, okay, now we need to make sure that rule is applied in this process as well. That's the main idea of ubiquitous language. So very like it will make us productive in the long term. That's again, the idea. The unique thing here that I want to talk about is this an industry, right? Where we have this client that we're working with. They make software for let's just call it the transportation domain. It's a bit more specific than that. It's sort of a specific niche, but this will be good enough for here. They are market leaders in like I think a $10 billion business. For building the software, right? They're not market leaders in transportation, but this software that runs these sort of companies. Their biggest clients are these sort of large, old, like 50-year-old companies that dominate a lot of the market. And they usually have like a huge mix of existing software that they bought somewhere, that they built, that they bought from my client, that they maybe have because they acquired smaller competitors and absorbed them, and now they have even more software for it. And because they're large and old, it's not just the software itself, right? The language that the people in this domain speak is messy and organic and ambiguous and all these things, right? It's a legacy language to talk about their business. Now, this client of ours, it's a 4,000 people company, I think. Yeah, something like that. The CEO, right? Not just the CTO, but the CEO has read Domain-Driven Design by Eric Evans, or at least chunks of it. Sort of understands what it's for and what the point is. So that's my example of, people are taking notice. And the vision he has is there's a lot of like in this industry, I think the number he mentioned was 100 new companies were founded in Asia, startups that, in this specific transportation niche last year. And so all these small startups are starting. They often turn to my client to buy software for them. Historically, this software, because my client as well has been sort of grown over the years by acquiring others and building new products, etc. So they're sort of in this transition phase of trying to streamline all their offers. But the vision he has is that they would not just come in and give you software so you can run your business on it, but they come in and they install a language in your organization. So a language really in the sense of here's how you should talk about these sort of business processes, about these things, about these rules, about these concepts. Right? Here's a well-designed, unambiguous language. It's based on our, decades of experience in this business. It is much better than the language that the large, incumbent legacy companies are using, which is a mess. And when you adopt this language that we give to you, you will be able to, first of all, amongst yourself, talk about these things in a good way. It starts from this notion of language as a competitive advantage. These startup companies will now be able to move a lot faster. Right? Large old companies usually build like moats around them, right? They make it very hard for newcomers to come into a market because there's so much regulation, because it's things are complex, etc. They use complexity as a moat to prevent competition. And then here, the vision of my client is let's not just give them software to deal with that complexity, but let's give them a language so that everything they can move fast, they have good understanding, they can skip the whole sort of messy discovery phase where you end up, with a sort of messy language for things. Um, I hope this makes sense, right? I think this is the first time I'm talking about this. I think it's just such a beautiful idea. Um, we've already seen it work a little bit in the small. We think it can work in the large. It's a really like unexpected advantage, I think, of the sort of thinking that is at the basis of domain-driven design. Yeah, so I mentioned that. The second one I wanted to talk about is bounded context as a really a tool for not just fast experimentation, but even fast evolution in general, and sort of getting the complexity, in a manageable state, etc. And so we can think of that as a subdomain, right? It's one of the aspects that we need to solve for if we want to run this e-commerce business. And then how do you decide prices? Well, you often start from supplier prices. What are we buying stuff for? We want some margins on that. We want to see maybe if we get a bit more sophisticated, we want to see how competitors are pricing their things. If they have campaigns, maybe we want to do sort of competing prices. Or it could be that we just decide like we want to be perceived as the more luxurious version of this thing. So we're going to price higher, or we want to be seen as the cheap alternative. So we're going to price lower. So there's sort of a lot of business strategy that is expressed in how a company deals with pricing. So that's sort of the subdomain, right? Is all these things. The bounded context is not a subdomain, but here it is in this first sort of simple example. The software designer said, okay, we have a pricing subdomain. Let's have a bounded context that has the same, covers the same things. We'll put all of these things together. We have a single language, a single model to deal with all these things. In practice, you'll probably want a single system or a single set of maybe microservices that's fit within this boundary. So within this blue greenish box, we'll have one language, one sort of model for that involves all these things. But if we're thinking about it a bit more and sort of seeing the experience and dealing with things, it's really two separate problems, right? And we can choose to separate them. I say we can choose because a bounded context is the designer's choice in the first place, right? It's like, how do we make a design that works for us? The invisible design, designing for the designers, and that also works for the business and for business strategy. So, like one of the reasons why we could split this up is that this margins bounded context is probably like a quite stable thing, right? So we're saying here in this example, stable in the sense that it's not going to change much. The exact values might change, right? We might decide, let's actually increase our margins on everything. Let's raise our prices. But that's a configuration change, right? But the structure of how that works, the model, the sort of language we'll use for it, we're not just sort of going to rename margin or something, right? It's just, a very sort of universal term. And a very concept of let's look at supplier prices, add our margin, and that's a selling price. That in itself is a very sort of stable idea. So if we isolate that, we can now say, well, this model that we have for that and this language are also very stable. We don't need to touch that much. That's a very good thing, right? Having sort of small subsystems or even large ones that are very stable that you don't need to touch often. And the stuff that is changing is maybe how we deal with competitor pricing. Why is it changing? Because competitors come up with new ways. We get new competitors, right? So we'll probably need to like scrape their websites. We need to monitor how they do things. We might change a lot. We might involve more like machine learning tools, etc. That's sort of a different um, you know, nature of this problem, right? One is a stable problem, the other is one where we sort of have to keep adapting and go evolving with the environment. So it's a very, in this example, right, it can be a very strategic choice to say, even though we think of this as one subdomain, pricing, let's actually in our systems think of this as two separate contexts, each with their own language. And that also means that if we need to make changes in the market prices bounded context, we don't need to touch the margins bounded context. There is going to be, it's not on this picture, there's going to be some communication between them because in the end, of course, we need to end up with a final selling price. But that can be probably like a very small communication line. We don't need to, they don't need to share a huge, language and model. So it gives us an advantage, right? We can now react because it's a smaller thing. We can have a team focused on that. It's often a very good idea to sort of align a single team with a bounded context. It's not always possible. We can't be naive about it, but we can react to this, and adapt faster to the market if we have a small system and a small model to think about and a small language as opposed to a big one. Now maybe we can think of even other problems, like maybe we wanted to get more experimental with our pricing. What if we like randomize prices and then A/B test them, or I don't know what other strategies could exist, right? But instead of saying let's try building things in this one huge bounded context that we had in the first picture, let's isolate that as well. Let's make this small bounded context to do some experiments, see if that could work. We don't need to touch the other systems. We're not sort of interrupting anything. We're not making it harder for people in those systems to work or to evolve things. And we can try some things, and then if we don't like it, we can easily throw it away as well. So it becomes a very sort of strategic tool to do things. And I'm reiterating, right? It's not just a separate system, it's a separate model. We think about this, we build its own model and language that is only about these concepts here, right? There's terminology in there. The language here is going to talk about randomizing and A/B testing. It doesn't even, it doesn't even need the word pricing there, maybe, or maybe it does, right? But pricing will mean something different than here in the market prices, and it will mean something different in the margins bound context. So in the first context, price means a supplier price or the selling price, very sort of logistics focused and commerce focused. Here in the second bounded context, price is a different model. It's the same word, but it means something else, right? Here it means a price that our competitor has, or maybe a change in a competitor price because they have a campaign, etc. Right? And then in the experiments, a price means something that we randomize and do A/B tests on. So it sounds like they're very closely related concepts, but they are still their own concept. And because we separate it, we get the benefit of being like very fast and trying things without affecting things too much there, etc. Right? We get this isolation.
Just while you're there, Mathias. So we have a question from Laura V, who says, "What happens then when part of the stable subdomain becomes destabilized? So with the whole market suddenly shifting."
Yeah. Well, I hope in this example here that the one I marked as stable, that's not going to be disrupted, right? In the end, every company in the world will have, or every company that sells stuff will have a supplier price and will want to have some margins on that. You can have exceptions, of course. You can say, well, we're doing a campaign now where we're selling under the supplier price for whatever reason, etc. Right? But the structure of that concept is not going to change, right? So that's at least one part that is stable that we don't need to touch much. And then, of course, there will be disruptions, right? If something changes in how the middle BC works, I don't really have an idea what that could be. But maybe in the third one, yeah, that could get disrupted because there's maybe new, machine learning technology, or there's other ways, or there's new discoveries. I don't know. I'm just making up stuff, right? But psychological pricing is this idea that a price communicates some feeling or intention. So if you see 9.99 euro for something, it wants to communicate that it's cheap. If you see like large round numbers, it wants to communicate that it's like, expensive and that and exclusive. Like, the sort of thing where if you have to ask the price, then it means you can't afford it. So that's psychological pricing. Maybe there's some completely new discovery in psychological pricing that sort of disrupts the whole thing. Well, you could start building that in isolation again, right? Or you could use this experiments PC maybe to try some things and move fast. So the fact that's the benefit I'm trying to get at here, right? If we already have this sort of clean isolation of things, some stable, some volatile, etc., then if a new disruption comes, we are already in a very good position to deal with that disruption, right? We already are sort of set up and organized in a way that we can say, okay, let's just try this thing in a small way. I think, yeah, I want to get like the idea of, oh, I see that Laura has a follow-up question. So the advantage is that you have an agreed way to express your assumptions on what is stable and what isn't. Yeah, excellent. I'll go with that answer. That's a very nice way of saying it, right? So if we already have bothered to think about stable and volatile things, then the next time something volatile happens, we can deal with that, right? We're sort of organizationally more sophisticated and can be less reactive and more proactive. Like, we think that this might be a new trend in the market. Let's already try a little bounded context where we can experiment. And we are already used to doing a bounded context for experiments, so it becomes sort of easy, right? That's the sort of thing I'm talking about. The opposite is a company that I worked with, a telecom company. And the reason they contacted us was because their competitor had come up with a new product. A product in telecom is really just a reconfiguration of the same things, right? There's mobile, data, internet, wired telephone, if people still use that, TV, that sort of things, and then the amounts and the quantities and the bandwidth, etc. Those are just sort of variables that they play with, and they package it, and it's a new product. So their competitor came with a new product, and it took them 6 months to react to that. That's very slow and reactive, and it's just because it took them 6 months from somebody saying, "Hey, we need to do something about it," to being able to define what that new product was going to look like, and then spend another like 4 months to just implement that in code. You're just too slow that way, right? If they were set up like this, they would have said, "Oh, let's," or they would have already like been trying things before they even, before they were even surprised by their competitors' move. So that's the sort of thing I'm talking about here, right? It gives you a sort of, macro agility in your organization to deal with these things. And so another way of looking at that, right? In most, this is what I'm talking about. Most ideas can't be executed. The symptoms are, you are in a meeting and somebody says, "Hey, what if we could do a feature that does this," right? And somebody will say, "Oh yeah, that will probably take like 6 months to. The system isn't designed for that. We'll have to like spend 6 months to build it. Yeah, that's probably not worth it." Discussion closed. And people are so accustomed to ideas being impossible like that, they don't even think of this as abnormal, right? They just think that's how organizations work. But in a more mature organization that has this sort of macro agility which DDD attempts to bring, if you understand your models very well, if you have this well-contained boundaries, and you can do this fast experimentation, you are in that same meeting, right? And someone says, "Hey, could we do this feature?" And then someone says, yeah, sure, let's do a proof of concept and then meet again tomorrow. And so by the next day, they have already like changed some things in the model because they know exactly where to change something, right? If you can look at the system and understand what everything is for, then making a change becomes extremely cheap. So by the next day, they have this proof of concept. Then they say, well, what would it take to do this for real? Well, probably another 2 or 3 weeks. They do it, they put it in production. It turns out that it doesn't, get the advantage that they wanted, and they can pull it out again because it's nicely isolated. How beautiful is that, right? You could just sort of start moving very, proactively and innovate. A way I like to think about models. So I'm using model very broadly, right? It can be our mental model. It can be how we talk, the conversational model. How do we talk about this domain? It can be visualizations. It can be in the code itself, like how the code expresses that model and that language in the test, etc. What is a model in science? A model is a set of beliefs that allow us to make predictions about a phenomenon, right? I can predict that if I drop my phone, it will fall to the floor. Why? Because I have a model of gravity, right? That model is good enough for me to understand that if I drop something, it will fall and maybe break. Of course, there's also like quantum mechanics and all that. That's a more advanced model that allows us to do more sophisticated predictions about natural phenomena. I don't need such an advanced model for what I do, in the daily life. But it's sort of this idea that a model is at the level you're at, in the context you're at, it helps you to make predictions. How does that work in software? Well, a model helps me to understand how a domain behaves. And then if I have that model in the software, it allows me to understand and predict how the software behaves. So under certain inputs, what will this software do, right? If somebody comes to you and says, somebody from the business say, well, what happens if, an order is refunded, but it was already shipping or half of it was already shipped and the other part is still in the warehouse and one item is in back order and then half the order is refunded, and like what happens, right? These sort of weird situations. And usually if they ask a question like that, it's because it's actually happening and they can't make sense of it. But if you have a good model, then you can say, well, sure, it's very clear. Like the model is showing me how it works, right? So the model becomes a tool for making predictions about the behavior of the system. And tests have like a similar thing, right? In science, that's experiments. We would call that a test. If I can very easily write a test that describes the situation that this person described to me. So, I can write a test that is really just, okay, here's an order, ship this part, put that part in back order, refund this part, and now tell me what happens, right? That's a test. So tests are like the other side of this, of how we can quickly understand our systems. So a model in software is, like in science, a tool that helps us make predictions about the behavior of the system. And the secondary thing is that if you have this well understood model, then it will help you make predictions of how the system will behave if you change the model, right? That's what software development is, right? We have an existing system with an existing model, which could be a good one or a messy, ill-understood one. If I can then say, I want to change this one rule here or this one thing, and I understand what the consequences of that change will be, then I have that predictability at the second order level. Right? That's extremely valuable because changing things now becomes very cheap. Why is changing software expensive? Because we don't know what the impact of the change will be. We don't know where to change it, what we have to change, what it's called. If we're breaking something else that was important to somewhere else, we need to do testing. We need to do a release for a small subset of users so we can see if it fails and roll it back. Those are the sort of things you do when you don't understand or you don't have trust in your understanding of the system, right? Then you need to be very careful about making changes. But if you do understand it, these changes become a lot cheaper and a lot faster to do. I'm not saying you don't have to test anymore or anything, but it becomes very obvious what the consequences will be. So, and if you can change things fast, you can evolve things fast, you can experiment fast, you can innovate faster, you can get ahead of changes in the market, and you can basically, win and achieve your goals. So that's very much this idea, right? So going back to these boundaries, right? They are not just like, I think that a lot of people in software engineers and architects have this sort of need for order, which, is fine, of course. But the boundaries are not just like, let's draw lines and have some order in this thing and or as an organizational purpose alone. It's really our tool, right? We get to choose these boundaries in a way that works for us, works for the business. And then you can basically any heuristic can be valid if you can, defend that in that context. So every bounded context, every boundary that you draw is going to be a trade-off. Why? Because software always wants to be connected. It's the great advantage of software is that if you want some data from this thing and data from there and some thing there, and you can interact with it from there using your phone, that's the sort of thing that we want from our software. As a comparison, before computers, if you wanted data from two different sources, you had to write a letter to the archive where they have that data, and they would copy that information from an index card or whatever, right? Or they would copy that information on that document and then send it to you. And that whole process took weeks. Now, if you want to combine two sources of data, you can just click a few buttons and integrate to systems. We have APIs, we have tools like Zapier and all that. We have integrations. So software really wants to have this connectivity, and of course, I mean not the software itself, but us as users, we want that connectivity. But as designers, we want decoupling, because decoupling, if everything is deeply connected, it becomes harder to understand. It becomes harder to evolve. Changing one thing involves changing three other things. It becomes more expensive. So we have those two sort of conflicting needs. One that is for, because that connectivity gives value. The other because decoupling makes things easier to evolve. So you're never going to find the perfect bounded context that is like the ideal line that minimizes decoupling and maximizes connectivity. You're always going to have to make trade-offs. And then how you make that trade-off can be anything. So this previous example was volatility and stability. It can be things where we want experimentation. It can be things like a perfectly valid way of separating models and language can just be, we have a different or organization structure. We have people in India working on this thing and people in Europe working on this thing. That's going to make it harder to communicate between them. So can we draw the lines in the software so that they don't need to communicate much? Can we give them each their own ownership or responsibility? But another way might be, well, this thing is built by the Java people, and this thing is machine learning, and that's going to be built by people who use Python. So let's just, even though it's maybe not the optimal split in terms of domain boundaries, I think it can be perfectly valid, right? That we give half of this domain to the machine learning people and half of it to the application people. But we can look at other reasons as well, right? What like the thing that gives us most value, let's isolate that from the things that are less important. or the thing where there's a high risk. Let's separate the high risk part from this domain from the low risk parts so that we can do, that's a strategic decision, right? Let's isolate some of these concepts so that we can deal with risk very well, and let's isolate these other concepts where you don't have to bother about it that much. So it becomes the way we divide our software system becomes a tool for being very strategic about it. Yeah, so any trade-off that makes sense for you can be valid, is what I'm trying to say here. The last thing that I want to mention is much more of an esoteric idea, but I feel it has always sort of, turned up for me in surprising ways. But it's this idea that like most businesses at some level of sophistication, they have models, right? They have ways to think about themselves. The really interesting thing about having engineers, software engineers make models, is that when software engineers make models, eventually it needs to compile, it needs to run. Right? That's a very interesting constraint that usually business doesn't have. Business has usually, when they model something, it can be hand wavy, it can be just some drawings on a whiteboard, it can be sort of, well, if we do this, then that will impact the business in that way. They can get more precise about it. There's, for example, Wardley mapping is a sort of modeling technique for business strategy that tries to be a bit precise for certain things. But there's no force that requires that model to be accurate. With software, there is. That's a very unique thing, right? We've never had that before. Software that didn't exist, that you could think of a model of something and that you would have tools that validate the accuracy and correctness of that model. In software that exists, right? It's if it doesn't compile, if it has bugs, if it doesn't behave the way you want it, then your model is wrong. And it's the fact that it's software forces you to get the model right? So as as engineers, as designers, if we are basically modeling the business, we are just like the business is modeling, people in the business are modeling their business, right? And business model canvas and all these things. But we have to model in a way that is accurate and executable and verifiable. And that idea can sort of push us up back towards the business. Like we can, if a business person comes to us and say, I want a feature that does this, we can say, well, you can't for this reason, right? It just doesn't work. It can't be made to work because that information doesn't exist, or we can't make decisions based on that, or it's just not how software works. That idea sort of extended to anything in business, like the idea of how do we validate that? How do we make that accurate? How do we get at a sufficient level of detail about the business? And that can be an advantage, right? You get a more sort of sophisticated, self-aware business, by which I mean the people in the business have a more accurate understanding of how the business works and how the processes works and how everything sort of fits together. I know this might sound a bit abstract and it's hard to give a very concrete example, but I just thought it was sort of a nice, more out there idea of how domain-driven design and the thinking that goes along with it can give us some business value. Yeah, I spent quite a lot of time with the questions, a bit more than I thought, but I'm happy to answer more questions or have a more open discussion. So yeah, thank you very much. And you can always, if you have to go, but you can always contact us for more questions. We'll publish this later. If your organization has a need of better software design and modeling and strategy, then definitely get in touch with us. And yeah, please ask anything you'd like to ask.
Great, thanks, Mathias. Yeah, we have a few questions coming in, so we can go through these. But as Mathias said, please contact us offline if we can't get to it. So yeah, the first one is Do you have an example of what a ubiquitous language could look like in practice? How could it be captured,
Um,
shared, and evolved?
yeah, it's going to be very contextual to your business. As I already said, if you're like a small startup, then just having a verbal agreement is a ubiquitous language, right? Like let's call it that thing, and then you just stick to that. It can be in documentation. It can be sort of embedded in the code, not just the code itself, but you can add comments to the code. There's this idea of living documentation, which is let's annotate things in the code and then have tools that extract this documentation about the language from the code and publish it in a way that the non-programmers can also access it. So, for example, if in the code I have a word, I don't know, price, and I write a definition as part of that code, and uh, this tool will now find all these definitions and publish a glossary somewhere. That's living documentation. But it can be in the, it can be in the Miro boards. It can be anywhere that you use language. The main idea is that you have some way of capturing that makes sense to your organization. If you put it in some file somewhere and nobody ever reads that, that's not the right way to do it in your organization, right? Then it's a pointless effort. But anything that makes sense for you would be a fine way to capture it and share it and evolve it. I don't have like a one way of doing things because everywhere we go, it's different, right?
There was another. There was
Yeah,
another question. It was partly answered earlier, but what about building support for DDD in organizations new to it?
yeah,
Do you find, for instance, that there are obvious places to start to build?
yeah. So it's not too bad when you're trying to convince fellow engineers or architects, and usually when it's hard to convince these people, it's because they've had bad experiences where stuff was made, very complex or bad in the name of DDD, and it was sort of based on a very shallow understanding and that sort of thing. Or if they work in areas that just don't really benefit from DDD, they won't see the advantage, and then it's hard to convince them. Or people are averse to change. That could also be it, right? That I have to learn a new thing. But convincing the business, that's sort of what I'm trying to address a bit here. Like hopefully I gave you some ammunition to sort of start explaining this at the level of a higher level in business, right? Like why would this make sense for us? Some of the obvious things like better communication and faster evolution. Some of the less obvious things like this idea of ubiquitous language as the competitive advantage, as the thing that we actually sell and install at our clients. But yeah, it's going to take you need to. There's a good start would actually be to look for resources that teach you how to talk to executives. These things exist. I don't have links right now, but there's people who write about it and who have on YouTube. I saw some stuff at some point. Like what is how do you communicate with executives? Why, like, how do they think? They usually are very busy. They are always bombarded with people with agenda. People with agendas are always bombarding them with things that they want. How do they filter, right? If you learn to do that, you'll already be a step ahead at sort of advocating DDD to them. The other thing that I want to mention here is this whole idea of adoption curves. You might have already heard of that or seen that sort of drawing of a bell curve where the first bit is the early adopters, the first sort of people who are eager to try this new thing. Well, new for your environment, of course. And then there's sort of a first early majority, people who are open to try new things, but they don't want to go through the hurdles. They don't want to do the experimentation. So you want to find the early advocates, the people who will be happy to mess around with it, to play with it, to fail, to try things, to do research and figure out things. And they like focus on them first, help them become the advocates, And then by the time you get to this larger group later, they are much more like they can say, okay, here are some of the ways we're going to do this. This is stuff that we've already tried. Here are some examples. Here's a case study. And then once you get those people on board, then there's the late majority. The late majority are people who say, you know, apparently that's the way things are done here now. Just teach us, right? They don't want to struggle. They don't want to try things. They don't want to experiment. They want it in a sort of very packaged way that allows them to just sort of adopt things, and they will follow along. If that's like how everybody does it now, then they will also do it that way. They will probably never be as good as your early advocates, but that's fine. You can't get everybody to be an expert. And then you have the detractors, the people who are against it. Like I've made a mistake often earlier where I was like trying to get them on board, but they suck so much energy of a change effort, right? They are like averse. They don't want to try things. They will find reasons for it to fail, right? They will say like, or they will try. You'll involve them in an experiment. The experiment fails, and I see it doesn't work, right? So you actually want to find ways of excluding those people so they don't drain that energy. You don't spend all the time like defending it, and you focus on this small group. Then get something done. Get something like find something that people, decision makers in the organization have always wanted. Find a way to deliver that and show how you've used TDD to do that. One example I have there that I did once was that was a long time ago when sort of very interactive user interfaces on the web were quite novel. I think we were using like Angular 0.6 or something at the time. So it was, and of course, people had done interactive UIs yet, but it wasn't super common yet. And in that organization, nobody had ever done that. Everything was sort of very server-side stuff. And so we demoed a UI that we made using Angular that was very interactive. But the story we told was not just about Angular as technology, but we showed how we had very good models, and those models in the backend allowed us to also have a sort of model in the front end that linked to that allowed us to do these things, and without going into much detail, right? But we were basically telling a story with something very visible, something that people wanted, that was like a new capability that this organization didn't have before. And we explained how DDD had been helpful to that. Not everybody understood really what we had done, but now DDD was sort of a shiny thing that more people got interested in, and it sort of allowed us to scale DDD a bit in the organization. So hopefully that gives you some ideas. What's the next question? LLMs and machine learning, and yes. LLMs are, of course, the very interesting, shiny thing right now, where a lot of people make a lot of predictions, and probably most of them will be wrong. I can already give you a little teaser. Eric Evans has been, for the last couple of years, been focused on LLMs. So Eric Evans is the creator of domain-driven design. Let's call it that, the godfather of DDD. He has been experimenting. He has some opinions. He will talk about that at DDD Europe, the closing keynote. So you have exclusive news here today. Part of the idea is that, like, of course, LLMs are being talked about as, something that will replace programmers. We will still need a way, even if we can replace programmers, we will still need a way to understand the domain and explain what we need and be specific about that and have like a language that is, so that's not going away. That's our role as sort of DDD people, according to Eric. I'm sort of conveying his ideas here, and I think it makes sense. But us as DDD people who can sort of bridge domain knowledge and think in language and models will become more valuable as some of the programming tasks will become more automated. Another side of this, I think, that is going to happen and is probably starting to happen, that is that you can train an LLM on all the literature. So I had energy trading as an example. If instead of me reading all the books, I could train an LLM on all the books, and then interview that LLM, that might be a way where I can get a lot more domain knowledge without having to use the time of the actual domain experts. Of course, it has risk. These things fabricate information, etc. So we're probably not there yet. I don't know if this will ever like really materialize where we will trust this enough to do this kind of work. But I think it's an interesting idea that the domain expert could be maybe not replaced, but supplemented with some, because the best domain experts are usually very busy people, right? We don't get a lot of access to them. Of course, an LLM doesn't have that problem, right? It scales. The next question: for a new team to adopt DDD, after explaining what it is, what's the first activity that you do? Event storming is my favorite way to start. It's very visual. You can sort of start in 5 minutes with technical and non-technical people without a lot of explanation. Everywhere we go with Artling, it's one of the first things we do. We often do it without training people first. Often we train them as well, right? But we can sort of start, without anything at all. It takes some facilitation skills, of course. So you would have to get a facilitator or figure out how to facilitate that yourself. If you're in this phase where there's not a lot of awareness of DDD in your organization yet, start small with a few early advocates. Find some time in the lunch break or whatever. Find a domain expert and don't say, hey, we want to do domain-driven design. It's this big thing. Just go like, hey, you know a lot about this stuff and I don't really understand this thing. Can you tell me what happens? Oh, can I write this down on a post-it? Hey, maybe you can write some post-its yourself because you know this stuff better than I. Let's put them in order, right? Let's build a little visualization of this. I haven't said any sort of technical or jargon or DDD stuff, but we are doing DDD. We are visualizing, we're modeling, we're talking to the domain expert, we're capturing the language, all of that. So definitely Eventstorming. It's there's other techniques, etc., but that one, for many reasons I won't get into, is just amazing. What's next? Training dev teams. How often are you asked? How should the folder structure look like? Yeah, that's a classic one. One answer is, a model is not just a folder structure. But it's one of the ways that you can communicate a model. So I do like to have a good folder structure. Another problem is that usually the frameworks are sort of imposing that everything that has the same pattern is together. All the entities together, all the value objects together, all the repositories together. From a DDD point of view, that doesn't really make sense. You want things together because they're logically together. You want the folder structure and the file names to sort of communicate a holistic concept, right? I have a product has a price. These things should be together. There's maybe a product repository. Maybe there's something else. Like if it a sort of very practical way to think about it is, if I implement a feature or I change a feature, I should have to do as little navigation across my folder structure as possible. If you have that, if you don't have to navigate much, it's because things that change together sit together, and that's just a lot more comfortable and communicates the model better. But in the end, if your framework doesn't allow it, then find other ways of expressing the model in the code and the architecture, etc. Right? It's not just, but it's a. I'm laughing because it's like the ultimate like beginner question with engineers often. I think that's all the questions.
Yeah, I think you're right. I think that was the last one. If you have any other questions, you can of course fire them over to Mathias directly on Twitter or Mastodon, but also through contact@ardling.eu. There's another one, so maybe I'll just finish my thought. And yeah, we're going to be doing more of these. So we'll have different topics. And so, yeah, you can also reach out and let us know what topics you want to be included next time.
The question is which project role or organizational role typically gives the most resistance when we introduce DDD? I don't know. I don't think there's like a pattern or anything. It's just in general, some people are averse to change. Some people worry it will make their life different or difficult, or that they won't be able to get it, or they just have another agenda or whatever. So there's no. But yeah, we spent an hour longer than I thought this would last. So thank you everybody if you stuck around this long, and yeah, thanks for joining. Have a great rest of your day or evening.